Hello guys and welcome to the last lesson in the 10.06 section. We're going to be looking at turning points and we're going to be looking at using the skills of factorisation, completing the square that we've done for the last two lessons. First of all though, can you leave space for your title in your LO, and can you spend 10 minutes working through these skills here on your retrieval task? So if you can pause the video for me and spend 10 minutes on that. Okay, so get your green pens out and correct the ones that you need to correct, mark the ones that you've got correct. Again, are there any skills here that you need to work on maybe? Are there any skills here that you're doing really well at? So when it comes to revision, you can give these less time, less attention. It's all about looking on how you can improve personally. So onto the first problem. Now we want to find the coordinates for the turning points of these curves. So first of all, we want to look at our equation here, our curve. So if we can complete the square for this curve, just like we did last lesson, so in our brackets we have x plus, split this, 5, all squared. We need to keep this and then take away this squared. So we can simplify these here. So 12 subtract 25, we're going to end up with negative 13. So now we've rewritten our formula here. And what we can do now is we can say, okay, so where will this curve be at its minimum? So this here, whenever you square any number, positive or negative, it will be greater than 0. So this curve here will be at its lowest on the y-axis when this here is equal to 0, because that is the smallest that this can be. So we need to set this equal to 0, so x plus 5 equal to 0. So for this bracket to be equal to 0, x must be equal to negative 5. We know that. So then we know the x value of our turning point. So now how do we find our y value? So if we have the x, we plug our x into here and substitute it in and find what our y value is. So it'd be minus 5 squared, which is 25, plus minus 5 times 10, which is minus 50. And then we're going to add 12, so we're going to end up with negative 13. So that is our first turning point. So if you can pause the video now and spend 2 minutes trying to solve the we do. And here we go. So we've got the minimum for this function here is equal to 11 at x is equal to minus 1. So x is equal to minus 1 and y would be equal to 11. So if we have a look, so minus 1 squared would be 1. 1 take away 2, add 12. So it's going to be 11 is our y. Yeah, that works. Make sure you've got that down. Let's have a look at another. So again, we're going to set this equal to 0 to help us with our completing the square. So we end up in our brackets with x, half of this split, minus 4 all squared. We keep the 12, and we need to take away this squared. So when we simplify this, this squared is going to be equal to positive 16. So 12 subtract 16 is going to give us negative 4. So now we know that our curve is going to be at its minimum when this here is equal to 0. So when x is equal to 4. So we could set equal to 0 there. X minus 4 is equal to 0. Add 4 to each side, and we get x equal to 4. So now we have our x. We plug our x is equal to 4 back into here, and that will give us our y. So y is equal to 4 squared minus 8 times 4 plus 12. So we get y is equal to minus 4 when x is equal to 4. If you can pause the video now and take 3 minutes to work through the WeDo. And here we go. So our answer for the WeDo is when x is equal to 2, y is equal to 8. Correct that if you've got it wrong. Don't worry if you have, we've got a few more problems to go through. A few more we can do together. So again, another very similar one. So if we set our equation equal to 0, so we end up with x squared minus 7x plus 12. So let's complete the square. So in the brackets we have x minus half this, 7 over 2 squared, plus our 12. And then we need to remember to take away our 7 over 2 squared. So we take away negative 7 over 2 squared. So we're going to square the top and get positive 49, square the bottom and get 4, positive 4. And if we do 12 and take away that, we end up with minus a quarter. So our turning point is going to be when this here is equal to 0. So when x is equal to 7 over 2. We plug that back into what our curve was at the start. Y is equal to x squared minus 7x plus 12. We plug our 7 over 2 into there, and we get y is equal to minus a quarter. So the minimum of our curve, the turning point, is when x is equal to 7 over 2 and y is equal to a quarter. So if you can pause the video now and spend 3 minutes trying to solve the WeDo. And here we go, here's our answer. So when x is equal to 5 over 2, y is equal to 23 over 4. So now our equations are getting a little bit different. Let's have a look at how we do this one now. So if we have a look, so let's first of all rearrange our equation so that we can get one side being equal to 0 like we used to. So if we subtract 4 from both sides, we'll end up with 8 over here and 0 on this side, just 2x. Then if we subtract 2x from both sides, we'll end up with 0 on the left. And then if we have negative 7x, subtract 2x, we're going to end up with negative 9x. So now we can complete the square like we used to. So x minus x, half this, so subtract 9 over 2 all squared, keep the 8, and then take away this 9 over 2 squared. So square the top and the bottom, 81 over 4. Let's simplify these here, which is subtracting fractions, which we can do. And our squared bracket stays the same. So now that we've got this, we can find the turning point of our curve. Because it's a quadratic, it's only going to have one turning point. It's going to be when this here is equal to 0. And it's good practice as well to write down that the turning point or the minimum is going to be when this is equal to 0. It's good practice and it'll help you remember why we're doing each step. So when x is equal to 9 over 2, this here will be at its minimum, it'll be 0. And then now that we have what our 9 over 2 is, what our x value is, we plug it back in to here to find out what our y value is, which is minus 13 over 4. So now if you can pause the video and give the WeDo a go, take 3 minutes for this. And so here we go. I've actually showed you here what the function looks like, what the curve looks like. And as you can see, what I've done is I've collected the terms onto one side. I have then completed the square. I can see that my x is going to be 5/2, and I can plug back in my 5/2 into my function to find out what the y coordinate or the f of x coordinate is. Let's have a look at another one using some of the skills from very early in the topic. So, times through both sides by 2 to get rid of this denominator. So we end up timesing the top by 2, 2x plus 2. And over here, our 2 on the top and 2 on the bottom would cancel one another. So we just end up at x minus 4. Now, as I've stated here, we've times through by a factor of x minus 3. So over here, we end up with x minus 4, x minus 3. And on the right-hand side, our x minus 3 that we times through on the top would cancel with our x minus 3 on the bottom. So now we've got something that looks like the last problem. So now we collect onto one side all the terms. So we'd subtract now 2x and subtract 2. Now we can complete the square. So x minus a half of this, x subtract 9/2 all squared, add the 10, and remember to take away our square of this. So we end up getting this here once we simplify. So our turning point is going to be when this in the brackets is equal to 0. So when x is equal to 9/2. So then we take our x value here and we'll plug it back in to this here. So once we've simplified our function, we'll plug it into this here. So once we've done that, we get an answer of y is equal to minus 41/4. Now that you've got that copied down, pause the video and take 3 minutes to try and solve the WeDo. I can see the answers are already there. We all can. But I want to see the method. It's the method that gets the marks. So here we go. So here's what the curve looks like. We can see that the turning point is somewhere around 2.5, which we've got there, and somewhere between 7/4. So somewhere just above half, just above 1, just above 2, sorry, as we can see. So now I want you to spend 10 minutes stating the curve's coordinates of the turning points for all of these problems. Remember to use the examples that we've done in the I do and the we do to model how you're going to tackle these. Be careful and take your time with these. These are tricky questions, but very satisfying.